Talks. Hope you all enjoyed the posters and enjoyed lunch. Okay, yay. It's my pleasure to introduce our first speaker for the afternoon, student doctor and anatomy fellow Clayton Oakley. If there was a prize for longest title, I'm just kidding. He is going to talk to you about his very interesting research on the anatomy of the thoracic spine to elucidate the validity of the thoracic rule of threes and define the anatomical relationship between the spinous processes and the transverse processes in the thoracic spine.
Can you guys hear me? Okay. So, just to save you guys 30 seconds, I will not have to read the title to you again, but so my name's, like Dr. Wright said, my name's Clayton Oakley, and I'm one of the clinical anatomy fellows. And the title of my presentation is The Anatomy of the Thoracic Spine, to elucidate the validity of the thoracic rule of threes and to define the anatomical relationship between the spinous processes and transverse processes in the thoracic spine. So before I get too far into my topic, I'd like to explain to all of you what the thoracic rule of threes is, because not all of you are osteopathic students or physicians. So the thoracic rule of threes was proposed in 1979 by Mitchell et al. To describe the relationship of the spinous processes to the transverse processes in the thoracic spine. Mitchell based the thoracic rule of threes on the caudal angulation of the spinous processes, and this was never actually validated by any other research that we could find in the literature. Why this is important is that this rule is currently being taught at osteopathic medical schools as the relationship between the thoracic transverse processes and spinous processes. So the thoracic rule of threes break up vertebrae into three groups. So group number one is T1 through 3 and T12, and they have their spinous process in the same transverse plane as the transverse process of the same vertebrae. Group 2 is T4 through 6 and T11. They have their spinous process in a transverse plane between its own transverse processes and the transverse processes of the caudal vertebrae. And finally, group 3, which is T7 through 10, have their spinous process in the transverse plane with the transverse process of the caudal vertebrae. We've practiced this rule in osteopathic medicine for years now, but in 2006, Gilhol et al. Proposed a new relationship between the spinous processes and transverse processes in the thoracic spine. He stated that T1 through T12 have spinous processes in a transverse plane with the transverse processes of the caudal vertebrae. So to relate this to the thoracic rule of threes, this is the same relationship as group 3, but the only difference is he proposed this for T1 through T12, the whole thoracic spine. Gilhol et al. Said the transverse process level and spinous processes were in the same transverse plane if the distance between them was 6 millimeters or less. 6 millimeters was chosen because the research suggests that the human finger is not able to palpate a distance less than 6 millimeters. This is of importance is because we use the same 6 millimeters for when we were defining if the transverse process and spinous process were at the same level. So now to get why this is so important. So for osteopathic physicians, they use the thoracic transverse processes to diagnose somatic dysfunction and treat that somatic dysfunction in the thoracic spine with osteopathic manipulative medicine. What the problem is, though, is that the transverse processes are very deep in the back. Due to this depth, we use the more superficial spinous process and the relationship between the spinous process and transverse process to help us locate the transverse processes in the back. But now we have this contradiction in rule between the thoracic rule of threes and Gilhol's rule. And looking through the literature, there is a very limited number of cadaveric studies done in regards to the thoracic rule of threes, and just any study really describing the relationship between thoracic transverse process and spinous processes. So this leads me to our research question. Does the thoracic rule of threes or Gilhol's rule more accurately describe the anatomical relationship of thoracic transverse processes to the thoracic spinous processes. So now to get into my methods. So the first thing we did was remove all the skin, muscle, and connective tissue to expose the thoracic transverse processes and spinous processes. We then palpated the most prominent part of each process and marked it in black. So here's an example you could see in the photo that these transverse processes do have a distinct, most prominent part. We then would take 3 photos of each thoracic spine to take measurements on 4 vertebrae. So photo 1, which was of T1 through 4, was taken at an angle to account for the kyphosis of the thoracic spine. The next 2 photos, which was T5 through 8 and T9 through 12, were taken parallel to the spine. So here's an example of the photos we took. So you can see where in black we marked the most prominent part of the process. And just to give you an example, here's the transverse processes of T1 and the spinous process of T1. And then we take our measurements from these photos. Overall, we had 44 human embalmed cadavers, 16 from here at Kansas City University and 28 others from the University of Nebraska Medical Center. We used ImageJ to take 6 different measurements per vertebrae to help us define the relationship between transverse process and spinous process in the thoracic spine. So now I'd like to go through each of these measurements with you to give you a better idea when we talk about them later in our presentation. So measurement 1 was the distance between transverse process level and spinous process of the same vertebrae. Measurement 2 was the distance between spinous process and transverse process level of the caudal vertebrae or inferior vertebrae. Measurement number 3 was the distance between transverse process on one side and the transverse process on the same side of the caudal vertebrae. This measurement was done on the left and right sides. Measurement number 4 is the distance between transverse process on one side and the spinous process of the same vertebrae. This was also done left and right. We took the angle between the transverse process on one side and the spinous process of the same vertebrae, left and right sides. And our final measurement was the measurement from transverse process on one side to the transverse process on the other side of the same vertebrae. We did a lot of these measurements to first test the rules and to also, while we were taking the photos, try to get as much information as we could to describe this relationship between transverse process and spinous process. We then used Excel to analyze our measurements and to test each individual vertebrae for both the Gilholt's rule and the thoracic rule of threes. So to test group 1 vertebrae for the thoracic rule of threes, we use measurement 1. To test group 2 vertebrae for the thoracic rule of threes, we use measurement 1 minus half the average of measurement 3 on the left and right, which is just measurement 3, remember, was the transverse process to transverse process distance, so we tried to find half that. To test group 3 vertebrae for the thoracic rule of threes, we use measurement 2. We also use measurement 2 to test Gilholt's rule. Following Gilholt's protocol, we used the distance of 6 millimeters or less for defining a vertebrae as following the rule being tested. So now to our results. So this table here is the mean and standard deviation for all our measurements for all 44 human cadavers, T1 through T12. There's a few of these numbers I'd like to point out to you. The first one I'd like to point out is measurement number 2, which, if you remember, we used measurement number 2 to test Gilholt's rule, and that was the distance from transverse process to transverse process level and spinous process of the vertebra above. This number was 3.00, which, 3.00, which was less than the 6 millimeter cutoff for, that we set pre our experiment. We didn't show it on our data, but all of them except T4 had their average below the 6 millimeter cutoff that we set. The next number I'd like to point out is measurement number 3, which was transverse process on one side to the transverse process on the same side of the caudal vertebrae. Both these numbers were around 24.6, which was within 6 millimeters of 1 inch, or 25.4 millimeters. The final number I'd like to point out is measurement number 6, from transverse process to transverse process of the same vertebrae. This number was 50.85, and this is approximately 2 inches, or 50.8 millimeters. The next thing we did when we analyzed our data was test all individual vertebrae for the relationship described either by the thoracic rule of threes or Gilhold's rule. So we saw that 26.7% of vertebrae follow the relationship described by the thoracic rule of threes. To break this down to in each individual group, 0% of group 1 vertebrae follow the thoracic rule of threes, 10.8% follow group 2 vertebrae follow the relationship described by the thoracic rule of threes, and 69.3% of group 3 vertebrae follow the thoracic rule of threes relationship. This was less than the 62.3% of vertebrae that followed the relationship described by Gilhold's rule. This isn't as related to the rules, but I believe this next 2 slides are very important for osteopathic physicians. 81.9% of measurement 3s, which is transverse process on one side to the transverse process of the caudal vertebrae on the same side, were within 6 millimeters of 1 inch. And 58.7% of measurement 6s, which were transverse process to transverse process of the same vertebrae, were within 6 millimeters of 2 inches. If we take out T1 and T2, which on average were bigger than 50 millimeters, and T11 and T12, which were on average was smaller than 50 millimeters, our number goes up to 76.7%. So now what does this mean? So as stated earlier, Gilhold's rule is not as accurate, or is more accurate than the thoracic rule of threes. So because of this, our research suggests that osteopathic medical schools should teach Gilhold's rule rather than the thoracic rule of threes because it's more accurate anatomically. We also believe that osteopathic medical schools should teach that there's a distance of approximately 1 inch between thoracic transverse processes of adjacent vertebrae and approximately 2 inches between thoracic transverse processes of the same vertebrae for T3 through T10. Here's all the people that helped me with our presentation, and I would like to thank most of all the donors who with none of this research would have been possible. Here's my bibliography, and now I'm open for any questions. Thank you, guys.
We have time for questions, and as with the morning session, if you'd like to come down to the mics.
Thank you. I just had a question about your image J analysis.
Yeah.
How did you ensure consistency from thoracic vertebra to thoracic vertebra when you're defining where you're taking your start and end measurements?
So that's why I used that black dot. I used the center of the black dot as and that's where we palpated as the start of each measurement, and we would go to the center of the other black dot. So is that what you were talking about? Or how do you, we also use that ruler, which no matter is kind of our scale, and we place that in the same place for each photo. So T1 through 4 we'd place it in the same place.
Yeah, so I understand it's for calibration, but I'm just asking, when you were getting your values, how did you ensure that between each sample, you ensured you chose the same spot to measure from consistently from sample to sample?
So that's what, from sample to sample, we couldn't stay, like they weren't all the same because we chose the most prominent part.
Okay.
And the most prominent part sometimes on a certain thoracic vertebrae would be, for let's say T1 would be maybe on the upper half of the transverse process. Sometimes it'd be on the lower half. So there was some variation in where we took those measurements from,
okay,
but that's why we did the most prominent part when we palpated of the spinous processes and transverse processes. Hopefully,
okay,
does that answer your question?
Yeah, that answers. Thank you.
Okay, you're welcome.
Any more questions? Okay.
Thank you, guys.